Yeah, you see my screen. Okay. So as I mentioned, we are going to be talking today about Kubernetes. Um, if you are already working on a microservices project, big chances are that you have already heard about the word Kubernetes. But what exactly is Kubernetes? Hopefully, over these 45 minutes, you will get a bit more you will have a more understanding of what Kubernetes is, what it does, what it is made of, and how it can help us. And Yeah, I hope that you will be a lot more confident to investigate issues. Maybe if it appears in your team, or who knows, this might be the start of your DevOps career. Okay, we can't really talk about Kubernetes without speaking a bit before about containers and what is a container. So at the beginning, we will have a brief look of what containers are, what are they made of, and why they are used in the context of Kubernetes. And also we will see how we can create such a container. After that, we will move on to Kubernetes. We will see its main features, and then we will go over its main structure, its main architecture. Actually, the guts of the Kubernetes cluster. We will see its components, how they interact with each other, and after that, we will move on to the most common resources that Kubernetes manages. There are a lot of them, but I'm trying to cover the most used ones in this talk. So you will see what is a pod, what's a deployment, what's a config map, and so on. And after that, at the end, I will show you how you can actually interact with resources on a specific server. Okay, so Docker containers. The usual way of developing an application is writing code locally and then deploying that code to a server. And from that point on, any difference between database connection, permissions, difference between environments of any sort may lead to errors. But with containers, we actually create like a packaged unit that has all the dependencies our application needs to run, all the configurations, so that we can easily deploy to any environment, being that that's the test environment, the production environment, and without having any issue of environment compatibility. Actually, microservices architecture evolved a lot out of this container development, because now you can split your application into the smallest components, smallest individual components, and you can work on them individually and deploy them separately, or have, I don't know, maybe you can have more instances of a specific part of your application, instead of just deploying your whole application as a whole again and again every time you do a feature or an update. Okay, so we go over the Docker file. So first, Docker is a containerization platform which helps us build and run and deploy applications inside of a container. The way Docker creates these containers is through Docker images. And to create such a Docker images, we use this Docker file. Docker file is just a simple text that contains like some comments that the Docker client will execute in order to create that image. And as you see, we have comments like copy, so that we specify where is the actual application source to copy inside the container. We need to expose some port on the container so that we get traffic from outside to our application, or maybe, I don't know, we want to run some commands when the container starts. And this is actually a really basic example of a Docker file. So as you see here, I have an application of a really simple Java application, and this is actually the file. So we have the from command, which specifies the GDK, the actual background on which the application should run on. On the command, we have the actual directory where the application is stored on my local computer, so that it can be copied inside the container. And then we have as the entry point, we have a command to be run when the application is when the container is starting. So as you see, it's just a simple Java -jar and the name of the application, and this is how a Java application actually starts. And this is a Docker file. But as I said, we need a Docker image. How we create a Docker image is like using this command here. So as you see, I have Docker build and dot. That means when I run this command, I am in the directory of where this file is residing in, and then I just specify a tag for our application, just a new app. And then whenever we run Docker run a new app, what Docker will do, it will just create a container based on the image created. This image will be added in our Docker local image registry. You can then push it to the online Docker image registry. But for this example, this will do. So this line here actually creates an image based on this file, and then adds it into our Docker local registry. And then we can just run Docker run and the name of the application, and a new container in a new Docker container will start based on this new image here. So actually, you can think of an image like the blueprint for a container, and where you specify all the dependencies your application needs and all the configurations. Okay, so basically, from what I showed you, Docker helps us with creating a container, with running a container. So where does Kubernetes come into picture here? Well, the thing that Kubernetes does best, and it's is best known for, is container orchestration. That means if you have like in your ecosystem of your application, you have multiple containers, multiple applications that needs to interact with each other, or maybe you want more instances of the same applications to be running at the same time on your Docker server. This is where you can't really handle it manually using only Docker, but Kubernetes is just this is what it does. This is what it helps us with, and actually it became the industry standard for container orchestration, because there are other container orchestration solutions, like Apache has one, Apache Mesos, I think, and even Docker has one, the Docker Swarm. But Kubernetes is the most popular and the most used one, and also it's open source. Okay, let's start now with its main features. So service discovery and load balancing. That means Kubernetes will and can and will expose your applications over a DNS name, over a domain name, service name, and or an IP address. And if it sees that one application, one container receives a lot of traffic, it can automatically spawn new instances of that particular container, like running on the same image, and then distribute the traffic between the two, so that your application stays stays up and it doesn't fail from the high traffic. Resource management. When it comes to resource management, Kubernetes actually knows all of his nodes inside this cluster. So we will see in the next slides what is a cluster made of. But just think about it as like multiple servers that Kubernetes manages, and he actually knows what resources are on each server, and then whenever you want to run you want to deploy an application on your server, he will make sure that that particular application will be deployed on a server in order to make the most efficient resource management possible. Self-healing, that means that containers that fail get easily restarted, and whenever you let's say you have a server, or as I said, a node. We will see in the next slide. Let's say we have a node where our application is running. Maybe that node crashes or something happens to it and is not available anymore. Kubernetes will deploy your application that was running there on a new healthy server, and then so that your application keeps running and your users and clients don't really feel that something happened with your application. Kubernetes also manages secrets and configurations. It stores and manages sensitive. It can store sensitive data like auth tokens, like SSH keys, like I don't know, passwords. And the nice thing about it is that being that they are like separate objects, these secret and configurations. I'll talk about them in more detail. They are like separate objects. You can just update those objects where you keep your secrets and configurations, and you don't have to rebuild your application in order to get the new value for those configurations. You just need to restart your application, and it will automatically pick up the new values for it. And then we have automated rollouts and the rollbacks. That means through some YAML configuration files or JSON, you can define the desired state that you want your cluster, your Kubernetes cluster to be in, and you can rely on Kubernetes to try to maintain it, such that maybe a container fails for some reason. It will automatically respawn an instance of that particular container, or actually image that we deploy. Okay, let's now jump into the guts actually of the cluster. As you see, we have two main components in the Kubernetes cluster, and this is the master node and the worker node. Master node is the main control server, which manages everything that I just mentioned, and we have worker nodes where your actual applications are deployed and where they are running. And we will take them one by one and see what they are made of. So we have the master node. We have the master node, and this is composed of four main components. We have the etcd, which is like a database used to store the entire configuration of your Kubernetes cluster. We have the controller, which checks the current state of the worker nodes, and if there are any differences between the way they should be in the way you have defined them, the controller is the one who will try to fix it and get rid of those discrepancies. We then have the API server, which acts as a gateway to our cluster. Whenever us as developers or DevOps engineers, we want to interact with our applications. This is the component that we will interact with. We will send comments here on the API server, and then forward the master node will delegate that comment to particular worker nodes. And then we have the scheduler, which is responsible with scheduling with deploying your applications on the worker nodes. And this is the component which actually takes into consideration those the worker node resources, and just what I mentioned before, Kubernetes knowing his whole ecosystem and architecture, and knowing at each moment of time how much space or CPU or whatever resource it has on each worker nodes, and depending on that, it will deploy your application on a particular node. So you shouldn't be expecting for your application to be deployed on a specific node. You should just expect that your application is deployed. Okay, let's move on to the worker nodes. So the worker nodes has again also 4 main components to it. It has a pod, which is, we will talk about it in more detail in the next slides. This is like the main unit that Kubernetes can manage, the main resource. You will see that a pod is actually a wrapper over a container. So let's do this. From now on, as I said, a pod is a wrapper over a container, or maybe more containers that are tightly related together. But Kubernetes can't actually manage a container in particular. Kubernetes can manage pods. So let's think about our applications inside the containers. Let's just think about it as pods from now on, because I will refer to pods in a lot in our next slides. So, and just to keep the vocabulary consistent. Okay. Cubelet. Cubelet is this is a component that actually receives the tasks that come from the master node in order to run any command or do any task. This is the component which actually execute that command, and then it will report back to the master node and tell it that the task is done or the task failed, and then the entire configuration and the state of the cluster will be updated in that etcd data store that we talk about. So in this data store, it will be updated, and a new event will come in that, okay, something went wrong or something went well. Okay. Also, it has a kube proxy. Kube proxy is the component that handles everything network related in the worker node. It makes sure that the node has an IP address attached to it. It implements IP local tables inside the worker nodes. It implements routing and other network configuration that you may apply to your node, to your applications. And then we have the container runtime, which is just, you can think of it as a component which brings images, as we talked before, from an image registry. Usually this container runtime is managed by Docker. And this is the component which will actually pull the image, the image that you want your pod and your application implicitly to run on, and this is the one who will take the image and will provided to the pod so that your application can run. Okay, and here we have like a main a high level view of what we just saw. So we have the master node with the API server, the gateway, the database, the scheduler, which schedules pods on worker nodes, the controllers, which checks the state of the worker nodes, and then here in the worker node we have this container runtime. As I said, it's the one responsible for pulling images for these pods, for the pods to run. We also have the Cubelet, who is expecting tasks from the API server, and then the Proxy handling the networking. Yeah, and here actually we have like a diagram of really, as I said, we as developers, we may want to see, okay, let's see which applications are running in our cluster at this moment, and we send a command to the API server. We will use for this thing. We will use kubectl, which is the Kubernetes client. And then the API server will forward those commands, those get pods or other commands, and it will forward them to the kubelets on the worker nodes, and then this one will do what it was asked for, and then will report back to the API server. And then on the other side, we deploy our applications in a Kubernetes server, so that we can actually use it, and actual clients use it. And the way clients interact with our deployed applications in a cluster is through Proxy, and with load balancing and everything else. We won't touch on the networking side of Kubernetes in this talk, but you should just keep in mind that through this component here, users can actually interact with applications and send HTTP requests and so on and so forth. Okay, so we saw what Kubernetes is. We saw its main features. We understood its main components and how they work together. Let's now go a bit more in depth and see how we can manage those objects that I was alluding to, like pods. A pod is one of the Kubernetes resources, and is actually the main one. And as you see here, the Kubernetes objects are defined using a YAML or a JSON file, commonly referred to as manifest files. And it's a good practice to keep these manifest files in a version control repository, so that you easily have access to changes on that on those files, and all the other magic that version control does. Okay, so let's start. A namespace is not actually an object that is defined as a YAML file or as a manifest. This is a way to actually group your cluster resources together. You can think of a namespace in terms of, let's say you have multiple environments that you want to deploy your application on, and you have a test environment with a particular configuration, some instances of database there, a particular version that you want your application to run on that particular environment, a production environment, of course. And you can see namespaces. You can use namespaces for this thing for this thing. So you will have a namespace for test environment, a namespace for prod environment, and so on. And as you see here, they are applicable for only some objects that can be grouped inside of a namespace, inside of a inside a particular group, but not for cluster-wide objects. We will see that there are some resources that are that should be accessible cluster-wide and not really be differentiated between namespaces. And as you see here, it's like the kubectl client is really verbose. It's really straightforward. So if you just want to retrieve the list of your namespaces in the cluster, you just hit kubectl get, and namespaces or namespace, it will do the same thing. If you just want to create a new one, you just hit kubectl create namespace and the name of the namespace. Let's say you want to get all the pods in a particular namespace, you just need to add this this parameter -n from namespace and the name of it, and it will retrieve you all the applications deployed in that particular namespace. And now, okay, let's move into pods. So the pod is the fundamental building block in Kubernetes. What that means is that if you want your application to be deployed on your server, you can manage a container by itself, but it needs to be run in this particular concept and object, a pod. So as you see, it's made of one or more tightly related containers, because maybe there may be cases where you have your application, in order to run, it needs to have running another application next to it that it maybe needs to communicate really tightly, and you just add those two containers and those two Docker images actually in the same pod, so your application can run smoothly. And as you see here, this is how a simple pod YAML file, a simple pod manifest file look like. So this part is like some metadata for Kubernetes to know what kind of pod, what kind of object to create. But what is the main focus for us is this part here, the actual spec for the pod. And as you see, it has like a list of containers, and on each one we can define a name for the container, an image, as I said, that image that I was referring to earlier, that will come from the Docker registry. And maybe we want to expose some port to external traffic, and this is how you can do it. Okay, moving forward. Okay, one thing to mention about pods. You can't really, as I said earlier about containers, that if they fail, they will be respawned, and this kind of management. You can't really rely on a particular pod to be running indefinitely. You just know that you want your application to be running at any given time, let's say. But if your application somehow fails, you would like for another pod to be spawned in its place, and to your application to continue running like nothing happened. And this is where the next Kubernetes concept, the deployment, comes into picture. So this is a resource that where we can actually define what pod we want to have running, and how many instances of it we want to have running at a particular time. So and we define that through the replica count. As you see, we have so this is the YAML definition for it. And here under the spec field, we have the replicas field where we specify, let's say, 3. And as I said, this will mean that we want these pods that we define in the deployment to be running in 3 same instances at the same time. So whenever one of the pods fails, crashes, something happens to it, it's the deployment's responsibility to notice it and to try to keep the replicas count as you defined it in the configuration. So yeah, as you see here in the YAML manifest file, you will have the numbers of replicas that you would like to your application to run on. And then here you just provide the pod template to be, it will be just something like this here, the containers from the pod. Okay, let's go over to the next concept, which is jobs. A job is used whenever you want to run one-off commands, one-off tasks on your cluster. So I don't know. Let's take as an example that we want to log into our console. It's like the most basic example. The date 3 times, and that's it. How we can actually do that? Well, job is the object that can help us do it. And how you can think about a solution for what I just the example that I just gave, like writing the date on the console. We can create a pod that's just running, I don't know, maybe some Nginx image or something like that, a really basic application on which we specify a particular command, like system log system date or something like that. It doesn't really matter. But what you need to have in mind here is that what the job, the concept of job does, will create a pod and will run the command on defined on it, and you can actually define you can actually configure how many times you want that command to be run. So for each command for each time you want your command to run, a new pod will be instantiated. So whenever so let's say it's the first time we want to run this command, we define the job. The job in turn will create a pod that will run that command, and that pod will end because that was its main its only responsibility. And the job object will count how many times the pods defined by it ran successfully. And after you reach your limit, your number of times of command execution, it will just end. It will just sorry, the job object will just be destroyed. And if you want to do another to send another command, you can just create another one or just respawn this one. Okay, moving over, we have cronjobs. Cronjobs is really related to job in the meaning that cronjobs creates jobs that are being run repeatedly. So let's say you want to at the end of each day to create some report on your database or something like that. In order for you to do that, you can just create a new pod that will do just that. A small application, a small microservice, if you want to do just that. And then you just configure here like through a cron schedule syntax the interval and yeah the interval on which you want this job to be run. And yeah, actually here the example has like it will write the date. I think it's each second here or each minute. I'm not really sure. I don't really learn the cron syntax by heart. But yeah, and as you see, it actually has a field called job template, which in turn has a template with an actual pod here. Okay, moving forward, we have volume. So in most cases, you would want your application to store data on a disk, or maybe run or maybe read data from some kind of file storage, let's say. And this is how applications and pods can actually interact with some directories, let's say, for file management. And for this thing, we have two objects. We have a persistent volume and we have a persistent volume claim. Let's see what's a persistent volume. This is actually the actual storage element in the cluster, and it's defined usually manually by the administrator. And this persistent volume has its own life cycle. It's not it's like separate from the pod life cycle. So the persistent volume will be up whenever wherever your pods accessing it fail or not. And yeah, in terms of configurations for this persistent volume, you can specify some access modes like read only, read and write only, depending on how strict you want your directory to be, your disk to be. And then we have the concept called persistent volume claim. And through this concept, we actually decouple the need for a pod to interact with a specific persistent volume. And where does and this persistent volume claim actually comes between these two? Actually, whenever you want your application to store some data, let's say, you only know that you want to store I don't know, let's say 3 gigabytes of memory. You would want to store 3 gigabytes of memory, and that means you will need a persistent volume with access mode of write, and a storage of at least 3 gigabytes. But maybe you probably have multiple persistent volumes defined in your cluster, and through this persistent volume claim, you actually define your request, your need in your application, and then you will let Kubernetes connect your pod to the appropriate persistent volume. It's just like with what I was telling you before. When deploying containers, they are deployed on the most resource efficient node in the cluster. This is how you should think about it when it comes to persistent volume and persistent volume claims. Your application doesn't really need to know on which particular persistent volume it stores data and it reads data from. It just needs to know that, okay, it needs 3 gigabytes of memory to store, and it needs to write data on it. And this is like an actual example of it. So you see here, this is the persistent volume, and you see we just define it. It's like it has a capacity storage of 10 gigabytes. It has an access mode of read write once, and on the node it will store the data and read the data from this particular path. And let's take a look on our pod. as you see here, the spec kind of got a bit more complex, but that's nothing to be scared about. We still have the containers here with the image that we want our application to run, and then we have this field. We have this volume mounts field where we specify that on the persistent volume that we will store, we don't really know on which one. We want to store data and read data from this particular folder. And as you see here in the volumes field on the pod level, we don't really add a reference to the this actual persistent volume, but to the persistent volume claim. And to do that, we need to define the third resource, which is the persistent volume claim, which says that okay, we need a persistent volume that has a read-write once access mode, and it has at least 3 gigabytes of storage available. And Kubernetes will actually do this connection between the pod through the persistent volume claim to the persistent volume, and that's how data is managed on pods. Okay, moving forward, we have ConfigMaps. ConfigMaps is the object that holds non-confidential data, let's say, in key value pairs. These are like configurations, maybe can be used as command line arguments whenever we run the application in our pod, and this is how we can define a config map. So as you see, we have a manifest file, and under the data field we have some key value stored. I'm not sure. I don't think that this is the best example, since user and password might be some sensitive data, but just for you to have a feel of what the config map can look like. So if you see here in the pod definition, then next to containers, we add the config map we refer to as also a volume, as we did with the persistent volume claim. So yeah, we just reference it by name. So it will be the volume. It will be of type config map, which has this name. Kubernetes will know that it has this kind of this resource with this name, maybe even in that particular namespace that the pod is residing in, and in this way we have access in our container, in our application. We have access to the configuration. Next is secrets. Secrets are really similar to config maps. The thing is with secrets is that they hold encoded data. So again, they are not really encrypted. So you shouldn't rely that this data here is encrypted and only some users can see it. Any user that have access to your Kubernetes cluster and to the namespace that this secret is deployed on can just decode it. I think it's by default is encoded with base 64, and it can just everyone can just decode it and see the values here. But it's just for example purposes. So as you see here in our pod definition, it's brought in just like we did with the config maps, but now we just instead of having here a config map, we refer it to by its secret name, and that's it. Now our my pod application based on the Redis image can have access to the secrets in this directory. And now, finally, we reach the point where I will actually show you how you can interact with these resources, and we'll show you how to actually create pods, retrieve deployments, update deployments. Let's see how it works. So kubectl is the client that helps us communicate with the API cluster, if you remember from the master, and we use it to send commands there. As you saw in a few examples, it's really straightforward. It's really well documented. Running kubectl explain has what it can actually do, and yeah, let's see. And with this parameter, all namespaces. If you want more details about the pods, like maybe IP address, or there are a lot more details that Kubernetes can tell you about a particular pod. This is how you do it. It's just this -o comes from -output, and it's like wide because it provides more columns to the detail for each pod. And then if you want to actually get the YAML file, the manifest file for a created pod, you just write kubectl get pod, the name of the pod, and then again -o as output, and YAML. You can also add here JSON. You can get more about pods with kubectl describe. Kubectl get deployments will list a particular deployment, and will if you then do kubectl get deployment, actually it will show you the number of the pods in this deployment. So if you remember, in a deployment we specify how many pods should be running, and this command here will actually retrieve us that list with details about each pod and how many of them are running at a particular time. Listing persistent volumes, retrieving config maps, services. This is like networking related. Let's say we want to create a resource. So we saw a lot of in this presentation, we saw a lot of manifest example files. So how we saw how a pod manifest looks like. We saw how a deployment looks like, and this is how you actually create a resource in your cluster using that particular file. So you just create a file there, and then with kubectl create -f from file, and providing the file name and or maybe the whole location of it, it will create that resource. And because this command here, kubectl create -f, because you here provide just a simple file, this is the reason why at the top of the file manifest definitions, you had those kind of fields where you specify this is a pod, this is a deployment, so that Kubernetes knows what kind of objects you are trying to create that particular file. But again, you can still create resources not by file, but with one-liners. So you just if you want to create a deployment, you just run kubectl create deployment, the name of deployment here, the image that you want your pods to be running off. And since you don't specify any replica, any number of pods that you want to be deployed, it will just start only one. Again, the same as with cron jobs, it just creates a cron job with a pod having this image and with this schedule, and running this command. yeah, so as I said, okay, that's this is every minute, the star dash one. If we want to update resources, let's say we have our application running in our test environment, let's say, and we do a fix. How do we actually deploy our new application to the cluster? The way we do it is through again deployments, and we just write set kubectl set image for the particular deployment. So we have the deployment called front end. This is the container name, and then we specify here the new image tag. So for each new version of your application, if you are familiar with Java and are working with Java, you create like a new jar, a new build for your application, and that new build will be needed in the Docker registry, so that it can be used in your containers and pods. And just running this command here, the kubectl set image for deployment, front end, and container, you also have to specify the name of the containers, because as I said at the beginning, a pod can have multiple containers. You will update all your instances of pods running at a particular time. So if you have 3 instances of your v1 application and you run this command, those 3 instances of the v1 application will be taken down, and 3 new instances of the v2 application will be deployed. Again, here we can have like multiple configurations regarding downtime, if we how many instances we want to be running, so that we at any given time, so that we don't have any downtime, even though we may in the time of the update, we may still hit some old versions of our applications. And yeah, you can set some percentage base of how many instances of how many pods you want to be running at any given time, so that you don't have any downtime whenever you deploy your new version of the application. And yeah, here are like a lot more commands for updating deployments. And also we can delete sources just using kubectl delete pod, or services, or we can delete namespaces, we can delete deployments, so on and so forth. Okay, and we can also interact with resources in the meaning that you can actually see the logs of your application with this line here, using kubectl logs, specify the name of the pod and the name of the container you want to see the logs for. Again, you can also you can also enter in the pod in your particular container in a and then you can see you can enter that particular container and just see what directories you have there, what files you have there, maybe mess around a bit with the files and everything. And yeah, the way you can actually interact with a particular pod is by using port forward on your local machine, if you are using Minikube, and just you can send actually direct request from your local machine to the particular pod on the Kubernetes cluster, and then you can also just directly run commands in the pod. That was it. Hopefully it was not really really much information at one time. Hopefully it was useful for you. I think so. Precious asked where can we get the slides. I'm not sure if you actually need a slide because the recording will be posted, I think, on the Codementor YouTube channel, and you can see there. You can see the whole recording, and yeah, it's fine if you miss some parts, or yeah, no worries. Okay, let's see if we have some question. How are secrets not encrypted but can contain passwords? Yeah, so the idea of secret management in Kubernetes is to just have some sort of implementation, and as I said, we have encoding data encoding, but if you like much better security with your secrets, there are tools that have really great integration with Kubernetes. It's the Vault from HashiCorp, I think. 1 second, I noted just for that thing. Yeah, exactly. So HashiCorp Vault provides secret management and data protection, and with advanced features like dynamic secrets on namespaces, revoking of the secrets data, and has like a really great interaction with the Kubernetes cluster. Okay, Rudy asked what was the best resource that helped you transfer skills from a full stack developer to a Kubernetes developer. Well, I'm actually not a Kubernetes developer. Yeah, I'm mostly a backend engineer. Team to investigate some in the good way on a particular environment, or something's happening. I wanted to learn to do that, so that I don't rely on them, and actually I can understand what's happening over there. Okay, yeah, exactly. On average, Rudy asked, on an average day, you write more code as a full stack developer or a Kubernetes developer, or you are on call a lot as a DevOps developer? Yeah, so as I said, I'm not a DevOps developer. Okay, Najma asked, I have a Python script that it's executed with a cron job. If the script fails, the post get deleted and I cannot check the logs. I can see that the job has failed. I think you can actually see the logs. Let me, this was meant to be at the end of the question. So if you have many other questions related this topic, you can reach me on LinkedIn, you can reach me on Codementor, and yeah, we can look over it in more detail. Okay, and yeah, Nashma, you can write me there because I need a bit more context. Pierre, does understanding Kubernetes with respect to two different languages improve understanding its features overall? I have seen a few articles using Docker Cube with R, some with Python. Thanks for any insight. Yeah, actually, it really helped me understand what happens to the code after I write. What happens with the application after I write the code? So how it can actually get deployed. How come we don't have any downtime whenever we deploy a new version of the application, and so on and so forth. How we can define the load balancing between instances. Maybe we have a particular part of the application where we saw that okay, this, let's say, account microservices receives a lot of traffic, and we can just spawn multiple instances of that particular service, that particular pod, because you saw now what's a pod, and then you can just you can just distribute the traffic evenly, and your application will keep running. Justice asked, if I'm using AWS or GCP, do I still need Kubernetes, and how would it work with it? Yeah, actually, AWS or and GCP work together with Kubernetes regarding container orchestration and image registry. Karine asked, what do you think of SUS Rancher? I'm not sure what that is. Yeah, I don't really know. I will look into it. Rudy asked, what is your favorite part about working in DevOps? I'm not working in DevOps, but yeah, it's really interesting. Yeah. Okay. So I see that there are no more questions. Feel free to drop. Hopefully, it really helped you. And yeah, it was really nice to meet you.